Hello, I'm Fido, your favorite tech-savvy dog pal. Today, we're diving into a classic, Applied Predictive Modeling by Max Kuhn and Kjell Johnson. This is a must-read for anyone serious about predictive modeling, and your favorite dog highly recommends it. In this video, we'll unveil some key insights, starting with Chapter 1. So, sit back, grab a treat, and let's fetch some knowledge. Let's get started. No fluff, just the good stuff. Now humans, I know when you hear predictive modeling, you think of complex algorithms. But hold your pause. Kuhn and Johnson remind us that models are just tools. The real magic is in the humans using them. It's about knowing what questions to ask, understanding the data, and interpreting results. So, don't get lost in the math. Keep your paws on the big picture. Imagine I'm training for a dog show. If you let me practice only on the same obstacle course every day, I might get really good at it. But what if you change the course? That's overfitting. We don't want models memorizing data, we want them to generalize. Tip: always split your data, part for training, part for testing. This way, we see if our model can handle new data. Oh, and if your data set has rare cases, like fraud detection, predicting recession risk, don't just split randomly. Use stratified sampling to keep those rare cases balanced. Overfitting is like me memorizing exactly where you hide my treats, but if you move them, I'm lost. Models do the same when they focus too much on training data and don't generalize. Tip: prevent overfitting by using simpler models when possible, cleaning and pre-processing data, using cross-validation to test performance on unseen data, before training, we need a clean data set. It's like prepping my play area. If my toys are everywhere, I'll trip. Data pre-processing removes errors, fills gaps, and transforms messy data into a useful format. Examples: missing data? Try imputation, filling in missing values with smart guesses. Skewed data? Use a box-Cox transformation to balance things out. Too many features? Use dimensionality reduction to focus on what matters. Predictive models come in two main flavors: regression, predicting numbers like fuel economy, and classification, categorizing things like grant approvals. Pick the right one for your problem, humans. No model is perfect from the start. We have to tune it, adjust parameters to get the best performance. Resampling techniques like cross-validation help find the sweet spot, ensuring our model isn't overfitting or underfitting. Tip: treat model tuning like testing different leash lengths. You want one that's just right for flexibility without getting tangled. Ever played 20 questions? That's what decision trees do. They split data step by step until they reach a decision. Random forests take it further by making lots of trees and averaging their results. And if that's not enough, boosting builds trees that fix each other's mistakes, like a team of top dog trainers refining their techniques. SVMs find the best way to separate data, like picking the widest gap between two dog parks. They can even map data to higher dimensions using the kernel trick, finding hidden patterns humans might miss. There's no best model, only the best for your data. Start with flexible ones like boosted trees or SVMs, but if you need explainability, go for linear regression or simpler trees. Always test and compare. All right, humans, we've sniffed out the best predictive modeling tips. Remember, understand your data, split it wisely, avoid overfitting. Tune your model, pick the right approach. Now, go forth and model wisely. And don't forget, if you like this, give a positive review, subscribe, and where's my treat?